Okay, welcome back students. In the last video I have explained you about one of the application of Ellingham diagram, that is extraction of iron from iron oxide. So in this video we will discuss two more applications of Ellingham diagram. So that is one of the application is extraction of copper from its oxide, that is cuprous oxide, and one more is zinc from its extraction of zinc from its oxide, that is zinc oxide. So first we will look into this copper oxide. So here, as you know, copper oxide, copper ores are majorly they are sulfide ores. So in this these sulfide ores, after this concentration process, they are directly made into roasted. So this is a sulfide ore which we have here. So then they are roasted. So you will get oxides. So now here you have to see the Ellingham diagram. So in the Ellingham diagram, if you see the line of this copper oxide, so you will get this line in the very top of the Ellingham diagram. So to reduce this oxide, it is very easy. If you can use carbon or coke at any temperature, because this line, the line of this copper oxide is present above all these at all the temperatures. Okay. So here, so it is very easy to reduce oxides of copper directly by heating with coke. So it is not copper. Make a correction. It is coke. Okay. So next point I have written is many of the ores are sulfide ores and some of them may have contain iron also. So here I have already told you most of the copper ores are sulfides. So these sulfides may also contain iron in it. Okay, so they may also contain iron within this ore. So you need to convert, or you need to remove this iron as slag also, so that we will discuss. So this is how the theory part of this extraction. So first it is roasted to oxide, copper oxide, it is made into copper oxide. Then these oxides are easy to convert it into metal. So this copper oxide, when it is reacted with carbon or coke, easily it will be converted into copper with the liberation of carbon monoxide. Okay, so this is the theory part of this copper oxide, or conversion of copper oxide to copper. Now the actual procedure of this process, or the conversion of copper oxide to copper, varies. So that I have written here. The actual procedure of this conversion of copper oxide to copper is like this. The ore is heated in a reverberatory furnace after mixing with silica. The first step is to mix this ore, the roasted or the concentrated ore. After the concentration and roasting, the ore is mixed with silica. Then it is heated in a reverberatory furnace. So why we need to mix this ore with the silica? So this is very important, because this silica, so I have told you, this sulfide ore may also contain some amount of iron. So to remove this iron, we need to mix this with silica. So this silica will react with the iron oxide present in the copper ore. So that will combine with the silica and form slags of iron silicate. The reaction I have written here, the iron oxide which reacts with the silica to form slags of iron silicate. So this is how we will remove the impurity, that is iron oxide, present in the copper ore. Okay, then copper is produced in the form of copper matte. This contains Cu2S and Fes. So after removing these slags of silicate, we will get copper, or copper in the form of copper matte. Okay, so this copper matte contains Cu2S and Fes. So I have told you this Fes, so it is removed in the form of it is converted into FeO oxide form, then it is removed in the form of slags of iron silicate. So the overall all the reactions taking place in this reaction I have written here. The iron sulfate sulfates of iron, so here it is there, so that will react with oxygen. So while we mix this with or the heat with in a reverberatory furnace, we will also add some amount of air. Okay, so that will react with oxygen and forms FeO. Then sulfur dioxide is produced here. Then this oxides of iron react with the silica we have added, then forms slags of iron silicate. Next, the remaining part, the copper, so which is our desired metal, so that is in the form of sulfide, that will also react with oxygen and forms oxide, copper oxide. In that case also we will get sulfur oxide. So here this copper oxide will again react with the copper sulfide to give copper metal. So in these all these three reactions, if you observe, so you will get SO2. So due to this liberation of this SO2 gas, evolution of this SO2 gas, so this copper which we obtained here, so that has blistered nature, so blistered appearance, so that means it has shining. So the copper obtained in this process, the copper is shining, so copper has some shining in it, so that copper is called as blister copper. That copper is called as blistered copper. So the blistered appearance is due to the evolution of SO2 gas. Okay, so this is one of the important, so you will get question why the copper is called blister copper. So you should write it is due to the evolution of SO2 gas. So this is how the extraction of copper from the copper oxide, the actual procedure of this method. So next, the third application of Ellingham diagram is extraction of zinc from zinc oxide, extraction of zinc from its oxide. So this extraction, it is not a lengthier procedure, so it is very simpler one. The reduction of zinc is done using coke at higher temperature. So in that case, in the case of copper, so we are not maintaining the higher temperature, because in the Ellingham diagram, if you see, the line of the copper or the copper oxide is present above the all the lines, so it is at the top, so no need to maintain at high temperature. At all the temperatures, coke can reduce the copper oxide. Now here, if you look into the oxides of this zinc, so somewhat you need to maintain some higher temperature than compared to the copper one. Okay, now here we are maintaining around 1673 Kelvin temperature. So here coke is added, ZnO, that is zinc oxide, directly mixing with the carbon, so you will get zinc and carbon monoxide. So directly, very easily you can reduce this zinc oxide. So here one more thing you should note, for the purpose of this heating, the oxide ore is made into briquettes with coke and clay. So this is nothing but it is like a small pieces like this. So okay, so they are all mixed and made like this. So the metal is distilled off. So at this higher temperature, this metal is so this we get in the liquid form. So then it is distilled off and collected by rapid chilling. So rapid chilling is nothing but sudden decrease in the temperature. So these are the applications of Ellingham diagram. Thank you.